This is the second video for chapter 12.6 optimizations. We are going to work on number 20. I think number 20 is a good exam question. It tests you a lot of different skills. So they want to maximize the revenue and profits. The company is going to manufacture X number of digital camera per week. The weekly price, demand, and cost equations are these two. So you have a price function, and then you have your cost function. So what price should the company charge for the camera, and how many cameras should be produced to maximize the weekly revenue? What is the maximum revenue? So because they're talking about revenue a lot, so we need to form a revenue function for number 20, right? So number 20, for the A part, first we need to find the revenue functions. So revenue function is R of X will equal to, hopefully you still remember, price times X unit produced, right? So we have a price function here, which is 400 minus 0.4x, and then we need to multiply it to X. So revenue functions will become 400x minus 0.4 x squared. So we have the revenue function, and then they want to find the maximum revenue. Okay, so we need to take first and second derivative. So when we found the first derivative, we have 400 minus 0.4 times 2 is 0.8x. We can use that to set it equal to 0 to get the critical number. So if we have 400 minus 0.8x equal to 0, 400 equal to 0.8x. Divide both sides by 0.8. 400 divided by 0.8 is what? So we got 500 units. So divide both sides by 0.8. We got x equal to 500 units, which means probably we need to double check with the second derivative test to see if that's the maximum point, but 500 units is what you're shooting for, right? So we're going to use the second derivative test to see if it's maximum. Okay, so we need to take the second derivative, double pi of x. So using that here, we got 400 becomes 0, and then we have a negative 0.8. So if you have a negative number, so that's the first derivative, this is the second. So our double pi of x equal to a negative number. Negative people is always upset, so the graph is going to be concave down. And when you have a concave down, this means you have a maximum value at the critical number, right? X equal to 500. Okay, so if we want to find the actual maximum revenue, we need to plug x equal to 500, the critical number, to where? So hopefully you know it's the original function out of 500. So looking at our original R functions, whenever you see x, plug in 500. So you can use your calculator 400 times 500, subtracting 0.4 times 500 square. Hopefully you will get 100,000, right? So that's your maximum revenue. On the question, they ask for how many units, how many camera, maximum revenue, and then what price. So the price, we're gonna need to plug it to the price function. 500 to price function. So P was 400 minus 0.4x, right? So we're gonna have 400 minus 0.4 times 500 for the 500 units. So if you use your calculator, 400 minus 0.4 times 500, you should get a $200 for the price. This is per camera, right? This is, yeah, per camera. Okay, so this is for the A part. So the A part, the answer would be when 500 cameras are produced, this is per week, right? When 500 camera produced per week at $200 each for the price. It brings in the maximum revenue of $100,000 per week. So this is the answer for the A part. Hopefully that makes sense to you. If you need to pause the video and write down some of the information, feel free to do it. So after that, we want to look at B. So this is for the revenue part. B part is what is the maximum weekly profit. So the next part, we are focusing on the profit. How much should the company charge for the camera, and how many cameras should be produced to realize the maximum weekly profit? So the second part, B part for number 20, because we want to look at profit, so we're going to need a profit function, right? So this is number 20, B part. So for my profit function, hopefully you still remember P of X would be the revenue subtract the cost. Alright, so your revenue is going to be well, we got it from the last part. Revenue was 400x minus 0.4x squared, right? Subtracting my cost function. Cost function is from the question part. The question part say cost function is this. So 2000 plus 160x minus 2000 plus 160x. Okay, so we use the revenue subtract the cost. Make sure you put in parentheses. So P of X equal to 400x minus 0.4x squared, subtracting 2000, subtracting 160x. Okay, combine like terms. P of X equal to, look like this is the highest power, 0.4x squared negative, and then x like terms, so 400x minus 160 is 240x, and then need to subtract 2,000. So if you know the end behavior, this is just a regular parabola x squared, and then a is negative, meaning it's going to be like this, right? Pretty sure you have a maximum thing going on. But we're going to use the derivative, so let's do the first derivative test. So first derivative test is p of x, p pi of x equal to negative 0.8x plus 240, right? This turned into 0. We need to set that equal to 0. P pi of x equal to 0 to get critical number. So negative, circle this thing. Negative 0.8x plus 240 equal to 0, and I can move the negative 0.8x to the other side, become positive 0.8x, right? And divide both sides by 0.8. Use your calculator. 240 divided by 0.8 is 300 units. So x equal to 300 units. Okay, we want to know if this is actual maximum, so we use the second derivative test. So second derivative test, we need p double pi of x. So looking at here, we have negative 0.8. So pretty simple. You get a negative number, so this is going to be sad face, concave down, with the maximum at the critical number. Maximum at critical number. My spelling looks horrible, sorry about that. Wait, one more time. At critical number. Alright, got it. Okay, so we have to find the maximum profit. So they ask for maximum profit. So we need the original p of x function, so p of 300 units equal to, my p function is here, right? Negative 0.4 300 square plus 240 times 300 minus 2,000. Okay, barely have enough room, sorry about that. So if you plug it to the calculator, hopefully you get $34,000. So the profit is not quite the same as revenue, okay? So that's your maximum profit. Okay, so, and they want to know at price what, right? So price at x equal to 300 camera. So we're going to need to use the price functions. The price function is what? From your question, 400 minus 0.4x, right? So plug it in there. You get 400 minus 0.4 times 300 camera. So you plug into the calculator, the price should be set at $280 if you want maximum profits. So maximum revenue is not that important. I think the more important thing is how do we get the maximum profit, right? So we're going to answer the question. We can say maximum profit occurred when 300 camera produce weekly. The maximum profit is at $34,000 per week at the price $280 each. So they're pretty long question, but they ask a lot of information, and you practice all your derivative skills and what it means when it's in the business context. So if you need to pause the video and write down some of the information, please feel free to do it. On your handout, number 28 is kind of like an extra example. If you feel pretty confident, you can try to set it up and check with my answer in a little bit. When you're ready, I can show you the answer. So I think you may have a homework question kind of like that, so I want to at least kind of show you that question a little bit, how to do it. So the question asks the rental income. 300-room hotel in Las Vegas is filled to capacity every night if they price it at $80 a room. If you want to increase the rent, for each dollar you increase, 3 fewer rooms are rent. So when the price increase, the demand go down. For each dollar go up, you rent out 3 fewer rooms. So if each rented room costs $10 for the service per day, so if you need somebody to clean it up, and that would cost you $10, how much should the management charge for each room to maximize the gross profits? And what is the maximum gross profit? So those are really business type of situation questions. So this is analysis type of questions. So we want you to try it out. So if you want to pause the video and try it, I know this one is a little bit challenging, but I'm ready to show you how you can do it. All right, ready? Okay. So we did that here. I can explain to you what's going on. So first of all, what you need to do is you should set up the variable. So we are going to say we let x equal to how many dollars you want to go up from the original $80 a night. So this is per night per room. We want you to think about, they say when you charge for $80, you rent out 300 room. But if you go up $1, meaning $81, then you go down 3 rooms. So instead of 300, it go down to 297 room. If you go up another dollar, $82, then you went out how many? You go down 3 more rooms, so it's going to be $82 for 294 rooms, etc. So this is how it works. And then next we're going to say, okay, the total number of room you're going to rent out if you increase the price would be 300 room, subtract, you lose 3 at a time, right, per each dollars you increase. So the room number would be 300 rooms subtracting 3 room times how many dollars you increase, right? And then the total increase for the profits is going to be how many room you went out times what rate you're charging, but don't forget you need to pay $10 service fee for each room. So total increase basically for the profit. Okay, so we have the function is we have 300 rooms, subtract 3x is how many room you're planning to rent out, and then the rate would be $80 plus how many dollars you're going up, but make sure you subtract $10 per room, right? So this is per room rate. So we try to clean it up a little bit, combine like terms, so we got that. For this one, I'm going to go ahead and take this derivative with the product rule, because like it's pretty simple. So when I take the first derivative, write down the first term, take the derivative of that, this is 0, this is 1. Write down the second term, take the derivative of that, just -3, right? So it's not too bad. So I distribute and I combine like term. So the first derivative equal to 90 minus 6x. Using that, I'm going to set that equal to 0 and then find a critical number. So I found out x equal to 15. So the 15, don't forget, is how much you want to raise for the rent, starting from $80. So the increase is $15. So together each room would be $95 per room per night, right? So that's the price for the room. So once we get that, we want to make sure that it's actually a maximum point. So we're going to do the second derivative test. We take second derivative of this guy. It just come up with -6. Because it's a negative number, so you're going to have concave down, which show me you have a maximum point at if your price go up $15. So to find out how many room we're going to rent out, it's going to be 300 room subtracting 3 times the $15 you increase. So you're going to rent out 255 rooms at that rate, and the rate of $95 per room. And your maximum profit, we need to go back to the original function, plug the 15 in there, and we find out the maximum profit is $21,675. So the final answer say you should charge $95 per room for a maximum of gross profits of $21,675 per night. So this is kind of like the workout solutions. I can put this to the top and pause it for a second. If you need to pause the video and write down the information, you can. And then I'm going to move it to the bottom half. And if you need to pause the video and write down this part, you can do that also. Okay? If you have any question, please email me and let me know. Alright? 12.6 would be part of the exam 3 contents. Okay? Exam 2 go up to 12.5. Thank you.